Welcome to the class, and also today's class we have a guest speaker, and this is also a PACTRANS webinar. You know, transportation has a lot of opportunities, and certainly we're in the situation to get more people come to work for transportation agencies and the industry. One important mission for this class and also for the PACTRANS Center is try to attract talents to work for transportation. Maybe you wonder, we've studied quite a lot of different things, exactly what kind of opportunities are available in transportation. And today we got a great guest speaker, Mr. Matt Neeley. We've been working together for multiple years. Matt got his bachelor's degree from Civil Engineering Department at the University of Utah and a master's degree from St. Martin's University. He moved to Washington in 2000 and worked as a state traffic system development engineer and was responsible for traffic operations electrical systems, WSDOT'S major electrical asset management program, and the commercial vehicle services, oversize and overweight permitting and weight station systems. Before joining WSDOT, Matt also worked as a consulting engineer for 5 years. Currently, Matt is the transportation director for Park City, Utah. He oversees the city's transportation system, which includes transit, transportation planning, parking, and traffic operations. The city has a population of 8,000. Maybe some of you have been there before. It's not a big city, but they have to deal with a seasonal peak of nearly 6 million visitors. You know, 8,000 people and 6 million visitors. So there are a lot of tourists there. And these visitors, you know, normally just travel around over about 11 square miles. The city is one of the nation's top recreational destinations for winter and the summer sports. The city offers free transit service through the city and operates a transit fleet of 40 vehicles utilizing both diesel and electric buses. The transit system carries approximately 2 million passengers a year, with 2/3 of the ridership occurring over just 4 months of a year. So you see, Matt has a lot of experience, you know, from both the private industry to transportation agency, and he's now managing the city's transportation, you know, dealing with the regular commute, you know, the quiet seasons, and also the very busy peak seasons, 6 million visitors. He certainly wants to share about his experience of being a transportation professional. And if you have any questions, you know, don't miss this opportunity. Okay, Matt, now the floor is yours. Let's welcome Matt Neeley.
Thank you very much. So Dr. Yin, hi, we've been working together for probably 15 or more years, something like that, when I was just a brand new engineer, and well, to the Department of Transportation. So what I'd like to do is, I've got a lot of information here. It's been a while since I sat in your shoes, but I do remember I didn't really like being talked to, and but I do like to learn. And so what I'd like to do is, I go through some of this information. I'm okay stopping and answering any questions that you have while we're there. I'd like to just take this opportunity to pass along some of my experience and just share with you any questions or any answers to questions that you have. I've been an engineer for about 27 years. I've really enjoyed my career. I've done a lot of different things. If you'd have asked me when I was in your place if I thought I'd be doing today what I'm doing, I wouldn't have had a clue. My career is just kind of, you know, I started taking courses in transportation because I really enjoyed my professor. I enjoyed it. I had fun with him, learning, and it just kind of stuck. And it's provided a great way for me to enjoy engineering. So, is it working? So where I've been, private consulting for 5 years, public service going on 23 years, so I guess that's 28 years, but State Department of Transportation. I came from consulting, and then they put me into as an ITS design engineer. ITS is made up of a lot of electrical, communications, fiber. I did not have any experience in any of that. And the DOT just started putting me in courses to learn how to do electrical design, to learn how to do fiber optic design. And then once you start learning those fundamentals, I started putting in BMS signs, running fiber optic cable down the shoulders, and building data stations, and building out the flow map that you see on the internet. Then I was, when I worked in consulting, I did a lot of traffic analysis. They called it TIA, Traffic Impact Analysis Studies. Anytime a developer comes in and he wants to improve an area, you have to assess the impact for that new development. And you have to get permits from whoever you're encroaching the right-of-way. And then I moved in, and so I continued to do that for the DOT, and then I became the state ITS design engineer. From there, I moved on state priority and programming engineer. I oversaw the entire capital program for the DOT, and that included safety. It included all their preservation, so paving, drainage, rock scaling, about $4 billion in assets at any one time. And then the state traffic systems development engineer, that was the last role I held before I moved on to the city transportation, as the city transportation director. I didn't leave because I didn't enjoy it. I left because I have 4 adult boys who moved out of state and went to college, and my wife and I followed them. So as you can see, there's a lot of opportunities out there. Lots of fun things to do if that's what you're inclined to do. And so as a consulting engineer, some of my responsibilities, even though my background was in traffic, in consulting, I didn't always have steady work as a traffic engineer. And so you just take projects so that you can have billable hours. And so I would get involved in utility design, sewer, stormwater, grading plans. Anytime you pull up to a restaurant and you wonder how the water's draining, how the parking lot is sloped, that's what you're doing, right? And then you're figuring out the parking design, making sure that you meet the city's requirements and managing impact fees. As a young engineer, I was required to do all my own material testing. I had to carry buckets of dirt into the lab, figure out what my compaction was, and then make sure that things were done to design. I liked it. It was fun for me. And then as a staff engineer, one of the biggest projects I had was getting ready for the Olympics. In the wintertime, it started out as my mentor just asked me to start designing a pump system for snowmaking. I had no idea what it was. Just told me what the specs were, and I had to figure out how to go about it. And as they fed me more information, I learned that it was for Soldier Hollow, which is located outside of Park City. And it was one of the venues for the 2002 Olympics. Awesome opportunity, right, to be part of something that significant and to be able to just see it develop so quickly. I keep doing that. And one of the things we had to do is we had a really tight timeline. For a young engineer, I felt like this was a lot of responsibility, but a lot of opportunity. And we had to have this ready for the NCAA competition. This had to be ready so that it could be certified for an Olympic venue. So you had tight timelines, you had a specific budget, and there was constant coordination. We had 2 big contractors that we were working with every day. This site right here that you're looking at, this is the main stadium area. We raised that area 26 feet. And what we did is the area that we carved out for the snowmaking, we built a pond that we filled with water, and we used that to build the snow in case there wasn't enough snow for the Olympics. We had those big rock trucks. If you've ever seen those, they use it like mining companies. We were running those constantly, just digging, compacting, and I was testing dirt. So, you know, my boss in the engineering firm wanted me to experience engineering from the dirt up, which I was really grateful for, because it really gave me an understanding about engineering. And this is just kind of a glimpse. This is one of the bridges. There were 3 bridges that we had to design and build. We designed them and we brought them in on a crane. So I just had to design the footings and the stem walls for them. And then this is the stadium area. There was an underground tunnel that connected the dignitaries into that main observation. So what I'm just trying to share with you is that your career can just take you in different places that can be really rewarding. And you'll be able to look back on it and see what you've done with the tools you've acquired. One of the other big projects I was involved in was the Defense Depot. And this was an old World War II military base. And the military was coming in and they were closing it. So this is located in Ogden, Utah. And what they decided to do is Ogden bought it with the Boyer Company, and they decided to convert it into an industrial park. And this is where my transportation picked up. So what we had to do is we had to redesign all the streets, all the utilities, and we had to figure out what the circulation was going to look like and how to accommodate the future growth of this industrial park. One of the neatest things for me is these intersections right here. 25 years ago, roundabouts really were not heard of in the United States. I was just a young kid out of college 28 years ago. And one of the problems, if you see this water tower right here, so this water tower, they considered it to be a landmark, and they did not want it gone. Even though it's not being used anymore, they would paint it, decorate it, treat it with lights in the holiday season. The community had grown to really embrace it, so we had to keep it. And at the time, this was an intersection that had multiple legs of traffic. We had a leg coming out right here. We had another leg going here. We had another leg going here. It was a mess for conflicts. And I had just recently graduated from college. My professor was from England. And he had showed us pictures about roundabouts.
Peter Martin?
Peter Martin.
I know him.
Yep. And so he taught us about roundabouts, taught us about multi-lane roundabouts. And I'm like, man, this is cool. So I just laid this out. I laid out the inscribed diameter. It was bigger than what's needed based on the volume of traffic. But in terms of a safety and reducing conflict, this was a solution that worked. And the city loved it. And so once we designed the first one, they had me do 3 more for the other intersections. So there's not a single signal on this property. And it's a mixed use, right? So you've got a lot of heavy commercial. You've got light commercial in there. And then you've got small businesses that are in there. So you're trying to figure out how to bring all this together. And as a young engineer, and I was the only transportation engineer working for this engineering firm. And so I would just call Peter Martin my professor, and I would talk to him and say, hey. And he would give me great advice. From there, I moved to Washington State. And so because of my background in consulting, I was supposed to come in as a rotational engineer, meaning they wanted me to go to one specific division within the agency for 6 months and then rotate to different places. I went to design for 6 months, and then I went to traffic for 6 months, and I worked for a guy named John Nesbitt, who was the region traffic engineer, and he's like, I think you should just stay here. So my rotation ended, and I just stayed and worked for him. And he threw everything at me that I was willing to do. And so I got this intersection. This is in Shelton. And what was happening is, if you've ever been to Shelton, Washington, you know that there was at one time a large logging operation there. And so just down this street right here, I believe was Weyerhaeuser. And every time these trucks would come in on this corner right here, they would hit that light pole right there. And they were knocking the PED push buttons off. They were knocking the lights over. And so Shelton just said, look, can you come out and help us figure out what's wrong? And so my job was to figure out, look at what the operation is, look at the intersection, and come up with a plan. What we did is we just widened the radius right there so that it wasn't such a sharp turn. We gave a little bit more room for the big trucks to turn, and we just redid all the traffic signals. And so when you're doing that, that's a great time where you start learning about all the things that go with it, with the dilemma zone and with the loop configuration and with all the wiring. These are things that I didn't learn in college, right? I did not learn how to design a traffic signal. Have you guys learned how to design a traffic signal? Yeah, I hadn't either. And so it was kind of a new thing for me, figuring out how to size the service, how to size all the conductors. But it's a big piece of what traffic engineers do, right? Figuring out all the new ADA codes that go along with things, and the audible pedestrian signals. You know, every time you're on a street corner and you hear the signals chirping, that's part of the current code. And so these experiences that I had were always just kind of rewarding for me. Just to be able to drive through, and I'd point to my wife and I'd say, I did that. And she'd say, did you say something? And then we started working on the Tacoma Narrows Bridge, the new bridge. And at the time, I was an ITS designer. And so what happened is we had the Gig Harbor side, and when they started reducing lanes on the existing bridge, the Willachet, the Gig Harbor side was just backing up. So at the time, the secretary, Doug McDonald, came in and said, I need you guys to put ramp meters in. I want ramp meters on all of the interchanges. And I want it done before school starts in September, and this is November, right? In government, typically things don't move that fast, right? When you think about the environmental requirements, you think about the plan specifications, estimate, the contracting process, something like that usually takes you a year or two. And he said, I don't care how much it costs. I don't care, you know, overtime, whatever. So me and my team, we just started working on this, and we designed it over the Christmas holiday. And we had it ready because we had to have this thing operational by September when school started. And so we had it ready to go. So by early spring, February, we were ready to go out with an ad. So that way everything could be built. Lesson learned here. Let me pass something along. If your boss ever comes out and tells you to do something like that in a major city and you haven't done any outreach to the community, you need to raise the red flag, okay? When you start making decisions like this, it's going to have fallout on the community, then there's going to be problems. For us, what happened is we had everything ready to go the first day of school, but there was so much traffic that it backed up onto all the city streets. So then what happens is we turned all the ramp meters off, right? But then that doesn't look so great because now you've just spent $2.5 million to build ramp meters that you're not using. So then we turned them back on, but we used the minimal amount of phasing signal timing, which made them kind of useless anyway. Moral of the story is, it's always important to engage the community. Make sure that you know who you're working with. Make sure you know who is at risk for whatever the project you're doing. That if you are working with the city needs to be in the room with you when you're doing design. Or they need to be in the room when you're scoping it, right? Talk to them, talk to the police, talk to all the stakeholders that you can think of that will be affected by this, right? I say the police because police is going to help you enforce it when people are trying to jump through that ramp meter. So this was, but it was a, you know, it was a great tool. It would work if you can do it, but you just got to make sure that you've got everything lined up. All right, the other thing is I mentioned to you guys a little bit ago is with ITS, we were doing the BMS signs and then also signing. Did you ever think about, have you ever been told that a static sign was the first ITS device? Anybody ever heard that? I learned that from Peter Martin. So the first ITS design that was ever introduced, is what they say in engineering, is as simple as a stop sign. It's information to the public that is using the system. And so that was part of my responsibility, was looking at our guide signs, looking at our roadway information, and how are people using it. You have to be mindful and just be aware of, you know, what is the message that you're trying to communicate and how well it will be perceived. There's all kinds of guidelines. If you haven't heard of it by now, many of you will come in contact with it, which is the MUTCD, the Manual of Uniform Traffic Control Devices. It's a handbook that any traffic engineer, every traffic engineer uses. And it provides those design standards for those signs. And sometimes there's situations where the MUTCD doesn't work for every situation. And sometimes you have to get creative, and then you have to work it out. The VMS sign, the VMS signs, they're a unique animal. Any idea on how much you think a VMS sign would cost you to put in? Throw something out.
5 million.
Okay. Anyone else?
100K.
What's that?
100K.
100? Okay. 100,000? 750? 750 is close. So this sign right here, they're about $250,000, right? And then when you get to the overhead gantry, you can spend anywhere from 500 on up. It just depends on how wide the road is that you're trying to cross, and then where your cabinet is for the controls. And this is where, if you like to be creative, this is really where your world as an engineer gets to be fun, in my opinion. Because when you're given the task of being able to come up with a way to communicate to the public, and you know you've got to come up with a solution to do it, and you get to pick the spot, and you get to design it, and you get to figure out, you know, how everything comes together. Where should you put the cabinet? Where, you know, what kind of a VMS board do you want? These new VMS signs that they have now, they're different than when I first started. You can walk right inside of one of these things, and you can fix everything from within the cabinet. Those are all things that you're thinking about. You're thinking about how to get maintenance in there. You're talking with the maintenance people as you're working on these, as you're designing these things. So these are just kind of the facts as you're thinking about it. How are you going to do this? How do you make all this stuff come together? The Tacoma Narrows So I had the opportunity to work on this one first. And what we had to do is, how do you guys think you get from the ground level up to the top? A big ladder. So as an engineer, would you guys all be willing to go up and do this? Go up to the top? Yeah? So my first experience is they have an elevator. And the elevator is in that side of the structure. And the elevator is shaped like an oversized water heater. It's round, and there was no light in it when I went, so the maintenance guy just handed me a flashlight. And so I'm just holding the flashlight, standing in this round container, and you just feel every joint as you're going up, right? Because it's just like, and you're just praying that it doesn't get stuck. But anyways, we went to the top and we set up a camera up at the very top of the tower so we could monitor the construction of the new bridge. And it was a full PTZ camera at the time, the latest and greatest, 20 years ago? No, whenever that was, 2000 something. And then we put another one over on this side at Doc Weathers Park. Actually, I think it was over there at Doc Weathers Park. And that way they could monitor the construction of the bridge, and they could do a time lapse so they could show how things were coming together. And then we had to design the communication cable that went all along the underside of that bridge. So we had to figure out how much fiber, and fiber is king in today's world. Back in the day when I first started, it was microwave or T1, or they called it a POTS line, plain old telephone. But now they've moved on to fiber. You can carry, one fiber can carry the equivalent of T1 or 28 T1 lines. And so when you think about that in terms of trying to move data, those are things that you get involved with over your career. And then you just start to get involved in the details and just help the contractor with different communication issues, different ITS issues. So I mentioned to you about the flow map. When I first started, the Olympic region, which is where I worked, which is in Olympia, they didn't have a flow map. This is kind of not the greatest image anyway, but it's kind of a cartoon map. And then what we did is we filled in data stations. And part of my responsibility was to put together a region ITS plan that identified where we wanted to put data stations. You guys know what a data station is? All right. So a data station is what measures the speed, the volume, the occupancy, and the classification of a vehicle that's passing over or through a lane of traffic. Okay? And so what the standard was is to put them every half a mile. And then when you have that density, you can use that to fill in a map. And that way provide traveler information to the public. The idea was at the time is to be able to provide this level of detail to the public so they could make informed decisions on their trip. It was an effort to try to reduce congestion on the roads. But I think as we can see, I don't know how well it's worked in Seattle. And then there's other devices, data stations, CCTV are the cameras that you see on the 50-foot poles. A HAR. You guys know what a HAR is? So have you ever seen those yellow signs that say tune in to station 1710 when lights are flashing? It's a highway advisory radio. In my opinion, they're one of the poorest ways to communicate to the public because you're trying to listen over the static and the poorly communicated message. We try to phase those out and use VMS signs. And then communications, looking at having a robust system. Something you have to think about as engineers is you have to think about the reliability and the sustainability of your system. The earthquake of 2001, what happened is at the time, a lot of our communication infrastructure was built on private communication systems. The Verizons, the T-Mobiles, the AT&T. So what happened is during an earthquake, they prioritized emergency services over everyone else. And then we lost control and communication of our system. So that's when we said, well, let's go back and let's revisit communications and figure out how to make ours more resilient. Looked at ramp meters, trying to put ramp meters on all of our on-ramps for trying to manage flow. And then automated enforcement. I feel like I'm doing a lot of talking, you guys. Are there any questions? Anything? Is this like really boring to you?
I may have a question.
Yeah.
Yeah, I'm curious about the data station you mentioned before. You said that it can collect so many kind of data, including the vehicle classifications,
Yep.
speed, density, occupancy.
Yep.
So I wonder how it can do that. So what kind of sensors will you use for that?
So make sure when you talk about occupancy, we're not thinking about people occupancy. We're thinking about vehicle occupancy in the lane. And then there's a number of different ways. The most reliable way is loops, right? It is where you take and you cut a metallic or an electrical wire in the pavement, and they're spaced a certain distance apart from each other. You know what that distance is, and so then it just calculates the time a vehicle takes to pass from one loop to the next loop, right? And then it can tell you how many vehicles are passing that loop over a certain time, and then it can tell you how long it takes for that vehicle to pass over that loop. So from those three things, you can get your speed, you can get the volume, you can get the classification, and you can calculate the passenger cars per hour per lane.
That's great. Thank you.
Okay? The other thing that we were looking at is safety. Everyone in here has probably driven through a work zone. Work zone crashes were one of our biggest problems in Washington State because people aren't slowing down. We had workers that were killed in work zones, workers that were injured in them, and we know that the speed is one of the biggest problems. So then one of the projects that was handed to me was to put together an automated enforcement tool, right? And to figure out how we could use automated enforcement to try to reduce speeds through a work zone. And so we used ITS equipment, so that way we could monitor traffic. One of the funny things is I had the feed coming directly to my workspace. And so I could see every morning I'd come into work, I'd log on, and I would see what was happening over the night with traffic. And I noticed about every morning at 2 a.m., somebody was doing about 110 through the work zone. And so it was the same time every night, and I watched it for a week. And so I just called my friends at State Patrol. I said, look, at this milepost, at this time, I am pretty sure you're going to find someone. And so the next morning, the State Patrol calls me, and they said, yep, we got him. And so, that's the thing that people don't realize is there's so much information out there on the highway. The way that we collect information, there's privacy things that we can't do, where I can't collect and save your license plate. I can't collect your IP address off your phone, but I can ping it. And so I can tell when a phone passed a certain place, and I can measure that. I can tell if somebody went to Starbucks and then made a right-hand turn at the nearest intersection. And so I can use that for origin destination type information. But so you just have to be mindful that information's out there, but there's laws that protect our privacy. So we can use it to help us in planning and operating, but we're not using it to spy on anybody. It's just to help us understand how behavior of people. And so Rush Road, this is down south. This is heading down towards Vancouver. And this is just some of the details of the location. I-5 at Grand Mound. This is near the Great Wolf Lodge, if anybody's ever been down that way. And so we were widening down there, and we just wanted to test this out, right? We wanted to see how it was working. We hired a vendor to help. You know, they set up their van, and they had the radar gun, so that way they were able to shoot the ticket and then send the citation. That's what it looks like. We had to go through legislation to do this. So this is something else that as engineers you may get to be involved in, which is developing language for laws within a state, or developing codes or statute for a local government. And so people will come to rely on your ability to process data and to make sound decisions, and to analyze things. And so the workforce, the posted speed was 60 miles, enforcement speed was 71 miles or greater. This is just giving you an idea. Barrier to no barrier transition at the Ground Mound project. This kind of gives you what it looks like from the speed enforcement. So when you see when it started, or before it started, back in 08, it really shows you I'm getting older now, doesn't it? And then when you see where after enforcement, and you can see where we reduced some of the frequency for when people were, or how people were using that corridor. And people became familiar with it, right? After they got caught, then they knew that there was a photo enforcement. They didn't know where, because we moved the van anywhere within the 8 miles. So they just knew that they had to slow down through that 8-mile section. But it had an effect, right? It reduced the overall number of people that were driving between 71 to 99 miles an hour. You know, just so you're aware, State Patrol maintains a log of the top 100. And it's not a good list. It's a list of drivers that are caught exceeding 100 miles an hour or more. And so that is a list that is regularly updated. And so we use that to help us understand as we're calculating things like the 85th percentile. There's areas of the state where the speed is greater than the posted speed. And so we had to go and look at what we can do to bring those speeds down. Anyway, we used to. I don't do that anymore. And so this is just more information, just giving it in a different lens. And then this is just a summary of, you can see where the infractions were coming from, which states. You can see that Washington State had 58%, Oregon 32%, which makes sense, right? It's close to the border, and California was 4%, and so on. So you can see the infractions issued, 1,271, and infractions paid, 1,002. So, and here's what the worry was. And the reason why we set the threshold at 71 miles an hour is because we were worried that we would have more infractions than we could process. And that's really what the case was. And so if we would have had it been lower, like 7 miles an hour, it would have inundated the court system to where they couldn't process that many. So you're just trying to manage it. And I think the outcome is what you would want, where we were able to reduce the speed and make it a safer environment for people who are working in the area. Years ago, Dr. Yinhai and I worked on a test site. And so I was I was the ITS engineer for the state at the time, and there's always different technology. And you'll find that when you're in your career, that someone's always got a new widget they want to sell you. Something that's going to make your job easier, something that's going to give you more reliability, better data. And so as engineers, they're always excited for something that's going to be better. And a lot of times they didn't have a way to proof it. So they would take it, they would write it into their contract, and then they find out that it doesn't work as what they said it would or how it would. So I came up with the idea. I'm like, man, let's just build a test site. Let's use this site for ground truthing. So what we did is I put loops here in the ground, right there and there, and then we put in this 50-foot pole. We ran fiber optic cable in here. I did a backup generator. The thing was bulletproof. And then we had our communication cabinet. And this went back to the TMC in Parkland, which is near Tacoma. And I would just test everything from Wavetronics radar detectors to Pelco, Cohu cameras. Anything that anybody said that could be compared to an existing system that we were using, I would wave it in. I'd say, let's test it, and then let's evaluate it. And let's see if it does what you actually say it will do. And then based on the recommendations that came from this is how I would pass information on. There's 6 regions in Washington state, right? And each of those regions are doing design for traffic systems. All the things that I've shared with you are elements that they are including in projects today. And they're looking for ways to solve some of the dilemmas that they're facing, whether it's a new signal controller or whether it's a new way to monitor traffic as a new data station. They're looking for something. So this proved to be a valuable tool for us. Just more close up. And then what we also looked at is, as the ITS design engineer, I would review all the plans from the regions that would come in. And I learned over time that the regions at the time were doing things their own way.
Sorry, is that 103 where you put that boat?
What's that?
Is that exit 103?
Yeah.
Okay.
Yep. And so we actually had one of these camera poles that a region designed, and because of the wind, it was vibrating so much that the camera would wash out. So what they did is they welded hooks on the top, and they took cables down to the ground and tried to stabilize it. I thought, man, what a mess, right? It's like an engineer shouldn't have to do that. So then what we did is I worked with our structural engineer, and we came up with the most rigid, stiff pole we could come up with based on conditions that we would see anywhere in Washington state. And we looked at the worst case for wind and for like a harmonic vibration. And so we said, okay, this pole right here can withstand a 100-mile-an-hour wind gust. And we can mount this many square feet of devices on it. So that way, if we needed to put a camera on it, if we wanted to put a radar detector on it, if we wanted to put a speed limit sign on it, or we tried to throw everything at it that we could think of, and then we designed it. And the cost difference for this, it added $1,000 or $2, onto the cost of the pole. So, and then this became the state standard. So that's where, and now all the regions, this is what they use today. And then you just throw in the other little devices, if you have an elbow that you mount onto a bridge, just working through some of those details. And then the partner to that is the foundation. I noticed that looking at all the foundation plans, the difference from the depth of the foundation typically was about 1 foot. But the cost to do the soil analysis, the geotech investigation, was about $6,000 a site. So a yard or two of concrete is what, $100? So what we did is we assumed a minimum bearing pressure for the soil, and then we just said, this is our new standard for our foundation. And at the time, we had a couple hundred cameras. Now the state's up to about 700. So take and multiply 600 times 6,000, and that's how much money you save. So along with being an engineer, you're thinking out how to be a practical engineer. How do you take the knowledge that you have and use it in a practical and wise way? And there's always people out there to help you do this. If you take your idea and you can share it with the right people, I didn't do this design. I took this to our structural engineer, and then I just shared with him what I was thinking, and he liked the idea. And so then we came up with this plan. So I think it's with those resources and those relationships, that's how you do it. And I think that's the most important piece that if I can pass anything along to you, engineering it's about relationships, whether you realize it or not. The success of your project will oftentimes depend on your relationships. When I first started consulting, my boss asked me if I knew what PE stood for. Of course I did, right? Professional engineer. And he said no. He says it's about politics. It's political engineering. I didn't understand that at the time, but I do today. It's important for you to maintain and develop relationships with people, with your peers, and with people that have different expertise than you. You don't have everything you need to solve every problem, but you can find people that do. And those people can help you develop a solid project. This is the generator. This is that ITS test site. This right here, probably shouldn't tell you this, but this is like the state network right here. And then this was the fiber cabinet. Are we out of time?
Yeah, if you want to take a 5 to 10 minute break, you could. It's all under your control.
Do you guys need me to take a break? Are you done with me?
Or you can continue until
Okay.
we need more time.
We can
Maybe
continue.
feel free to use the restroom.
Do you guys need a break? Take a break.
It's on the live.
All right, you ready? Jump back in. Okay, so just to kind of share with you another opportunity. You know, earlier in my career, this happened, I think, in about 2010. I'd been in traffic for almost, with the department for almost 10 years. And my boss suggested that I try to broaden my, my professional career and learn more about the department. And so I took a job as the state priority and programming engineer, which meant that I was responsible for prioritizing and programming the improvement and preservation program for the state. And what I wanted to do is just kind of give you a glimpse of what that included. And what I was working with is all the subject matter experts. And so you're working with the people in hydraulics, you're working with your geotechs, your structural engineers, your traffic engineers. You're trying to figure out what we should program for construction and delivery. And so that's where your engineering background comes into play, is because you're looking at those details and you're trying to see if we have squoze every bit of life out of an asset or if there's something we can do to extend it. As an example, we were, the legislature has prioritized and programmed our pavement condition. So they say that the condition of our roads should be 92% in fair or good condition, which means no rutting, no cracks. It should just be a smooth road. Well, many of you have probably driven on the roads, and you know that not all of our roads fall in that condition. The problem with that is the cost to maintain it. One lane of traffic to preserve it is about $250,000 a lane mile, right? If you have to rebuild it, it's more than $1 million a lane mile. And then if you know what a chip seal is when you see the kind of an exposed surface and it's not as smooth, and you can see the aggregate on top and it looks like there's just oil over the top. That is about, $60,000 to $80,000 a lane mile. At the time, we were looking at about $100 million deficit in being able to meet the target set by the ledge. So we were trying to be creative. And we had said any road that has an ADT of 5,000 or less, everybody knows what ADT is, average daily traffic. If it has 5,000 or less, we're going to chip seal it. Well, to be creative, we said, well, what if we raised that to 10,000? One, can the roads handle it? Because a chip seal doesn't have the bearing pressure of hot mix asphalt. And so we did some work. We found out it would work. And that gave us enough money by reducing the cost to maintain our roads to be able to get the performance up and be able to take care of what we needed to in that time. And so those are some examples of real life problems that engineers get to deal with. And so when you're looking at these different categories that I worked in, when you're looking at the mobility, you're looking at the HOV lanes, you're looking at bike routes, you're looking at mobilities, collision, CALs, CACs, and PALs. So a CAL and a CAC, what we're doing is we're trying to figure out how to reduce fatal and serious injury accidents on the highway. And what we do is we collect the accident reports that are provided by State Patrol, and then we try to determine what were the contributing circumstances. How can we prevent that from happening? Is it engineering, education, or an enforcement issue? And that's when you would just take that list of those locations, you send it along to the region, and you ask them to look at it and evaluate it. And then you've got collision prevention, interstate safety, risk, rest areas, signals, right? There's a whole long list. Fish barriers, noise reduction. Fish barriers is a huge issue in Washington State, right? If everybody knows about that. They're supposed to be compliant by having all of the barriers removed by 2030. And it was a billions of an issue. I'm curious. I don't know. I haven't kept tabs on if they're going to make it or not, but it was a heavy lift. And then chip seal, hot mix asphalt, concrete, and then the HMA past due, chip seal past due. There reaches a point on a road that once it's past due, it doesn't really do any good to try to fix it. You just let it go. Once it's past due, it's a rebuild, right? You can't go and just do an overlay. And so you just plan for that, and then you're just like, you just keep going. And then structure preservation, special bridge repair, movable bridges. We have about 3,300 bridges in Washington State. And we were always working to make sure they're being seismically retrofitted, and then looking at if they're scour critical. And then other facilities, unstable slopes, weigh stations, major drainage. So each of these have a subject matter expert. My job was to work with them and to get their priorities from them, and then prioritize it against the budget that we had available. Anybody ever been skiing to White Pass? So this is Highway 12. And this happened probably around 2015, 2016. We had a huge winter rain. Lots of rain was coming down. There was a culvert somewhere over here with an outfall out here. This culvert got clogged. And so then the water coming down the hillside just started coming over the road and undermined the road. Our guardrail is just like dangling in the air. This became a state of emergency right here. So we had to work with our federal highway administrators. The governor's office declared a state of emergency, and we had to stabilize this road. This was, if you didn't take this road to get to the White Pass Ski Resort, you'd have to go all the way around to from I-90 up through Yakima and come back around. So this is exciting, when something like that happens, right? That's when you come together with your peers and you start figuring out how to solve this problem. This is when engineering's fun. And then also, Washington State has a statute. It's called joint and several liability. And so in Washington State, if the DOT or the government is found negligent, and then they can be named in a lawsuit, then they're the ones who could be put on the hook for covering the cost of the lawsuit, right? And so, I think it's important for you to, you're always trying to manage risk. And sometimes engineers are called into court to testify on what it is that they did or they didn't do and why did they do what they did. And so you think about that, and you're using the design standards. You are looking at the guidelines, and sometimes they call it engineering judgment. You're using your judgment. But there are times where you may be called on to answer why you made a decision the way you made a decision. It's not a bad thing, right? And then engineers, right, love their processes. And what we were doing with this is we were trying to figure out a way, because there are so many needs. If you're working for a state government or a city government, you are always trying to figure out how to pay for the needs that you have. And how do you identify those needs? So we worked with a team, and we came up with this process called the integrated scoping process. And the overall reason for this was to identify what are the needs and how do we fund them and how do we deliver them? And who is responsible for delivering them, right? And so, you get to use your skills as an engineer for developing these types of processes to help people understand how decisions are made. And I think that's where the thinking comes in. With the skills that you're learning in school, it helps you to develop stuff like this. This right here was a corridor study. As the State Traffic Systems Development Engineer, I was involved in leading the south segment. And so what this was is this was to look at Roger Millar, the current Secretary of Transportation, said I wanted us to come up with a strategy that could make a positive change on the system, right? What an incremental improvement. And what are some improvements that we could do in 0 to 4 years? And this was done by pulling together focus groups. There were 10 focus groups that we conducted where we pulled in people from law enforcement, from planning, from engineering, from local agencies, and we just wanted to hear every idea that they had for reducing congestion on I-5. My scope of work was from Trosper Way, which is down by L&I on I-5, up to the King County line. And our job was to say, okay, what can we do to reduce congestion? Some of the, and overall there was a couple hundred ideas that came out of this group. And sometimes the engineers, we kind of have a reputation for thinking that we're always right. Usually we are. But I think that but the public doesn't like that, right? The public likes to, they like to be brought along. They like to know that what they are bringing to the table is being heard. And so I think that's important for us to acknowledge that and to make sure that we're not forcing a solution on them, that we're bringing them along and making them part of the solution. And that's how we got to these strategies. We took the 200 and we pared them down. And we said, what are the things that we can do near term? And that's where we came up with doing ramp meters. We talked about doing hard shoulder running, and then upgrading signals and doing a transit signal priority, and then expanding the model. And teleworking, which obviously this happened before the pandemic, and then expand van pool use. So these were just some low-hanging fruit that we could do near term, and then we identified the champion. And so you notice that the DOT was not the champion on every single one of these. You see that the DOT had a couple, but then you had Thurston Regional Planning Council, and then you had intercity transit, which is a good place to be. You don't have to own everything, right? It's good to have other people, other champions that can help lead things and that can help us accomplish what it is we're seeking. And then other issues, working on HOV lanes. What we were doing is we were looking at the HOV lanes through Seattle. We wanted to, because we knew that the HOV lanes weren't moving as fast as we thought they should, and we wanted to see how many people were actually 2+. So we hired a group of students from UW to stand on the overpasses and to count the number of people in cars. And, there's places within Seattle where the number of people who are using the HOV lane is more than 60% with a single passenger, with a single rider. And so that's when we did increased enforcement. We paid State Patrol to work overtime, and then we just started handing out tickets. And then what we did is we started looking at what the fee structure was and making the fee more painful for people who were going to break the law. Instead of just a single $150.
Like $500.
Yeah. Yep. That's pretty good. See? It worked. And so what we did is we wanted to look and we wanted to look at how all the HOV lanes were working. And so all these locations, we can thank UW students for counting those locations for us and letting us know how they're being worked, how they're operating. And we were doing that regularly, so that way we can report and just see if we need to do more enforcement, or if the laws that we have in place aren't working and we need to change them. And so every year during session, new bills would be introduced by the legislature, and then that's where part of the work I would get involved in is reviewing those bill analysis. One of the things in Washington State that's always been controversy since in the last decade, is triple trailer combinations on commercial trucks. Commercial carriers want to use triples because they can carry more product for less money. The problem is those triple trailers have a whipping effect, right? And some of the lanes that we have configured in Washington State aren't 12 feet. Some of them are 11 feet, or they may be 10 and a half feet, which doesn't give you a lot of room for forgiveness if you've got that triple and it's swinging wide. And so every year for the last 5 or so years, the commercial carrier group was hiring a lobbyist to try to get that law changed. And so we would always have to provide testimony and provide justification on why we don't think it's a safe strategy. HOV lanes, reliability and benefits, monitoring the results from HOV lanes. We want to make sure that it's actually, if people are jumping in the HOV lane and they're paying money for it, that it's helping them get where they want to go faster than if they're sitting in the regular traffic. And so monitoring, I would work with the UW students, and we would look at the data, and we would provide this annual report. We'd work with the Seattle division, and then we would put this together so that we could share what it looked like. Commercial vehicle services. A number of years ago, there was a trucker, and there wasn't a place for him to park. And so he pulled over into a vacant lot, and he just thought it was a safe place to sleep. While he was sleeping, his truck was broken into, and he lost his life. And so then the legislature created a law called Jason's Law, which happened to be the name of this operator. And so Washington State was looking at this to see how we could support the commercial vehicle services and how we can provide places for them to rest, and just trying to understand the magnitude of this problem. And so we were identifying all the hot spots where we were finding where truckers were pulling off. I'm sure everyone here has seen a trucker pull off onto the shoulder to sleep. It's because there's no place for them to go. And so we're just trying to figure out, that was one of the strategies I was working with Weigh on, and Yin Hai's group on a truck parking pilot, so that we could figure out where the empty stalls were and then provide an app to the commercial vehicle service industry so they could pull it up and say, oh, there's 5 stalls 3 miles ahead. Just trying to give them that level of detail so that way they can help plan their trip. And then the other part is weigh in motion and scale facilities, inspection. Trucks are a big deal, right? Many of you probably know from some of your transportation classes, if you haven't had it yet, is looking at the impact that large trucks have on our roads. Because of the weight of the trucks, they're hard. And we want to make sure that the trucks are operating under their legal weight limits and that their trucks are in good condition, meaning their tires are at the right pressure, meaning their brakes are good. Everything is in working order. And so we invest in inspection facilities, scale facilities. We partner with State Patrol, and then weigh in motion. And I'll cover a little bit of that. I'm trying to jump through this, you guys. And this is just an example of a location where we were looking at putting a weigh station facility. And just kind of what the configuration looks like and some of the detail that goes into that.
So, sorry, so like the weigh stations, like, is their primary service like basically like ensuring that trucks are operating at load capacity?
Yep.
It has nothing to do with like importing goods or like, is that data used for anything else or for the service?
So the way it works is if a truck driver wants to, he or she can get a transponder from us. The transponder then becomes an electronic fingerprint of that truck. It records what the cargo is, it records who the driver is, and it reports all the information that we need for that load. If a driver is coming our weigh station, we have an overhead detector that will pick up that transponder and download it into our federal database. If that trucker is good to go, he or she will get a green light, and they can pass. If they don't, they automatically have to come in. If they come in, we are going to weigh them, and we are going to inspect their vehicle.
And they're going to charge you too.
Yeah. Yep. So, and if they're overweight, we will take them out of service. And we will either make them divide their load or come up with another option. But we're not going to let them back out on the roadway. So this is an example of a weigh station, right? This is also like a State Patrol detachment facility. So you've got State Patrol who's positioned in here, and then often you'll see there's like usually there's a scale pit, maybe on the other side of that wall, and then there may be an inspection pit back behind the building where they can pull their trucks in, and they can go underneath and do their inspection. You know, a facility like this, we spend about $16 to $20 million on to build it. Interesting thing, you guys, I think 2 years ago, Ridgefield Weigh Station, it's a fairly new facility. In front of the building, we put concrete barriers, right? And the barriers taper from, you know, like 6 inches up to like 3 feet. This Cadillac came into the work zone doing about 100 plus and hit that barrier and clipped the top of the roof and then came back down. Craziest thing I'd ever seen. It was actually a suicide attempt. Yeah. So, and then the other part is the scale pits. These scale pits, they cost about $1 million to build. Now, the interesting thing is we had built a scale pit, and I can't remember the date, but we had built one, I think, 10 years ago. 5 years later, the thing was rusting out. And these sidewalls here and here, were starting to collapse in on the scale. So we couldn't use it anymore. So we had to close that scale pit down. Then I just wanted to understand. And the local engineers were saying, well, let's just rebuild it. And I'm like, time out, man. Let's understand, why is it failing? So then we started looking in and looking at the rebar. We started looking at the concrete. And then we figured, I'm like, how is it that we can build a bridge abutment that can last for 50 years, but we can't build a scale pit to last for 20? So we started looking at this, and we realized there were things we could do similar. And so what I reached out to the bridge engineers. I'm like, what can we do here? So then these comments right here are from our bridge engineers. And they said, well, what we can do is we can change the concrete design, and we can change the rebar and make them all epoxy coated. And then we can change our steel to make it all stainless steel. Any connection will be stainless steel. And so then we just changed it for a little bit more, you know, for about 10% more, but we'll get another 15 years additional life out of it. So instead of 5, we're going to get 20. And to me, that's a pretty good investment. So I think the question for you as engineers is, don't be afraid to ask why.
How often are trucks supposed to get weighed
It depends on the transponder. So if a driver has a transponder and they should be weighed before they leave with their load, right? Because now, and every state is different. So if you're a carrier and you're crossing state lines, you have to obey the laws of that state. So if you have a transponder, if you have a Washington DOT transponder and you're coming into our state, but you're coming from Oregon, you'll probably have to be weighed coming in across the border. But then once you've done that, you're free to pass all the way to Canada, if you're good. All right, the other part is commercial carriers. And so with our commercial carriers, if we have an oversized load, we are processing the permits. We are verifying the route that they are going on and making sure that whatever it is they're carrying, that they can make the turn, that they can make the height, and that they've got the right pilot car, and they've got the pilot car certification. And, you know, as an example, over the next, I think, 2 years, Washington State, they're going to be bringing in 100 windmills from the south up to the east side. And all those had to be permitted. So, and it's going to happen late at night, right, when traffic is at the lowest, and it's going to happen over time, not all at once. And just so you know, Washington State has the authority that they can stop a carrier and pull their permit right where they stand. And so you have to make sure that if you have that role, that you've done your due diligence, because now time is money for that carrier, right? And then the other thing is with those weigh stations, since it's a shared relationship with the State Patrol, there was always conflict on who's supposed to do what. State Patrol would say, that's your responsibility. The DOT would say, no, that's your responsibility. So we said, let's put an MOU, a memorandum of understanding. Let's document and define the roles and responsibilities. And then we will make it a living document that we can update every year as things come up. And so I think we did that in 2018. And what we did is we came up with 9 categories, and we put the details in for each category. And these were blessed by both sides, by State Patrol and by the DOT. And this is what it looked like, right? Just a number of, each section had a description like this, and then it identified who had oversight, who was responsible for the planning side, and who had funding. Sometimes all the boxes were checked for both groups. We would share the role. And that reduced a lot of conflict between the two parties. And then we just tried to make it, and then the other thing we did is we met weekly with the State Patrol to work out issues. When I first came in to this position, our relationship with the State Patrol was not good, right? The parties just hadn't learned how to communicate with one another. And so the important side is to listen and then talk about what each other's struggling with and being open-minded. And I think through that, we were able to come to an agreement and work out. You know, when I told you about that car that hit that barrier going 100 miles an hour, in the MOU, it said that the DOT is responsible for maintaining that. So we went in and we pulled out that barrier. Thank you. We pulled out that barrier and we put in a crash attenuator. So if anybody came in again doing that fast, the attenuator would just absorb the impact and they wouldn't go flying. That was $50,000. And State Patrol and the DOT absorbed the cost for the safety of the facility. It was the right thing to do. And then we just established the period of performance. The MOU would be reviewed and signed every year. And there's a jobs agreement, and it's a joint operation plan between the DOT and State Patrol. They meet every November, and these documents are reviewed and signed at the same time. So this is an example of the weigh station today. I told you about the cost. This is what we're trying to get to. Okay, this is what they call a weigh in motion. And what this is this has all of the technology that building has. It can measure the weight. It can check the ID of the driver. It can screen the transponder, and it can send it along. It can send it along to your computer if you have the IP address to connect to it. And then if a driver is operating at an illegal weight, that officer could see it and then radio and go after that driver. So the difference is this is about $350,000 to build instead of the 16 to 20 million. This is where we would like to get because we can do more enforcement in more places. What's that?
How is it weighing? Is there still a scale under the ground?
Yeah, so there's bars in the ground, and so they run these bars that are calibrated, and if you'll see these long lines, and the pavement has to be very smooth, right? You can't have ruts in it. It's got to be pretty level, and it's concrete typically. So every site we do that, but that's the direction we're headed. Right here. So that just helps you see how we're doing it. State Patrol loved it when they saw this, just because they could go and they could start putting them out in more places, and especially in places where they know they've got a lot of commercial traffic. And then the tire anomaly system was something new we were looking at just before I left. And what this does is this allows us to monitor the individual tires of a truck. It will tell us if the tire is flat, if it's underinflated, and we can bring that truck in, and we can do a more visual inspection. And it will tell you which tire it is, right? It will highlight it so then you can bring the truck in. You can go right over to it and do the inspection. The other thing we're doing for our truck parking pilot, what we tried, didn't work as well as we thought it would, did it, Way? This was a wireless detector. They're about 3.5 inches square, and they're about 2 inches high. And we can just core a hole in the pavement, drop it in, fill it full of epoxy, and then this is wireless, and it detects a magnetic surface. So if a car drives over it, it can detect it. And, they make all kinds of claims. You know how I talked about a test site? These guys claimed that a battery could last for 10 years. I think we got, 3? If we're lucky, less than that. It's great near term, but even still, the accuracy and reliability is not that great. And this is just a hole, it's a 4-inch diameter hole. We drop it in there, cover it with epoxy. This is where I am today. So I'm in Park City, and these were some of the problems I was handed when I started there. Emergency access to resorts, public safety in neighborhoods, impacts on resident quality of life, neighborhoods, traffic, transit stuck in traffic. And what we did is I just said, I want to understand the days that all this is happening. What are the worst days of the year? So we pulled the data together. The days in red are the worst days of the year. These are the days when the resorts are open. These are typically the days when we have great snow. And we have a max peak of 61, and then the yellow are just peak days. That's where it's heavy, but it's not as bad as the red. And as an example, when I say peak, it could take you 45 minutes to an hour to move 2 to 3 miles. Okay? You could walk most places faster than you could drive in Park City. Areas of focus, looking at our circulation, transit, parking, guest decision-making, resident impacts. And then what we did is we had to put our plan together. We put a comprehensive plan and we had to take it to city council, 5 members of the council plus the mayor, and we had to say, here's how we propose to solve the problem. We've identified a circulation plan around a base resort. We're recommending that we put in a park and ride lot, and we want to increase transit frequency from 30 minutes to 20 minutes, and we want to raise parking. We want to push people to the outside of the city. And so if they don't want to pay for parking, we offer them a free option with free transit. Okay? And then these are the people. Remember how I talked about engagement? We brought these people to the party. And we met with them weekly or monthly, depending on who they were. Utah DOT, it wasn't weekly. Everybody else on that list, we pretty much met with them weekly. And we brought them in a room. We talked about what was working, what's not working, and what are their ideas. The tiebreaker for me, Park City came up with a strategy. The resorts came up with a strategy. I said, let's hand them both over to a consultant, a neutral party, and let's see what they come up with. The interesting thing is the consultant said, well, we like some of these strategies and we like some of these strategies. So we'll put them together. And you know what, you guys? It reduced congestion significantly this year. It was the most positive response the city council has heard in years. And then we put together microtransit. Microtransit, if you don't know what it is, it's a first and last mile service. It uses minivans, and what it is you go on an app and you say, I live here, I want to go here. It uses an algorithm, and it says, okay, based on the time of day and where you're going, I'm going to pick you up here, and I'm going to drop you off at this bus stop here. And then you're going to take this route to get to where you need to go. Okay? All this service is free in Park City. To try to reduce traffic, it's encouraging people to use public transit. This is just a transportation network. These routes right here, we looked at ridership. We wanted to know how many people were using these systems. We wanted to know what time of day, and we used it to help us identify how long they should run, what's the frequency, and where should they be going, right? Where are the densities in the community that we need that are underserved? And we found that there were some places, like right here, this gold route, we found that we were spending $250,000 a year to pick up 8 people a day. So we said, forget the bus, we're going to put a minivan there, right? And we're going to make it on demand, and that minivan can pick up those 8 people every day, right? And so instead of spending $250, we'll spend $50. And these are the routes that we increased. These routes were 30-minute routes. The community was saying, look, we're tired of waiting for buses. We want a more reliable service. So we said, okay, 20-minute service. We went to the council and we said, we can do this for an extra $500,000. They said, great. And then resort parking. The neighborhoods were irritated that people were parking on their streets, and they were worried because the skiers were parking in the business parking lots. So what we did is we changed the duration of the parking. We said you can only park here for 2 hours, and then we changed some places, like the parking garages, to $30 a day. The resorts were charging $25 a day. So we made ours a little higher, and then we said, if you don't want to park at either place, you can go park for free at a park and ride lot, and we'll bus you in. Deer Valley, I'll go through this real quick. I know our time is up. Deer Valley, it's a beautiful place. It's great to look out my window and see this place. What's that? Okay. Yeah. And then they're doing a base expansion. And so as an engineer, my responsibility is to look at the analysis and just to see if everything makes sense. The level of service, does it make sense on what they're proposing? Want to understand what their assumptions are. the things you're learning in this class, I think follow this really well. The things that I learned in this class are things I think about all the time. When I'm in meetings, when I'm talking to people, those concepts are how I break things down and how I approach a problem. And then this is the bus drop-off. And they're going to add about 250 condos. So think about that in terms of demand and what that's going to put on an existing system that's already at capacity. Where this is going to have a charging station in it, it's going to have an overhead, so our buses just come in and it connects to the bus and it will charge them. It will give them an extra couple hours of runtime with about 15 minutes of charge time. Resort's paying for that. So I think that's the end of my presentation. So I think to summarize things, you can see there's a lot you can do with a degree in engineering and transportation. I think it's important just to be mindful that sometimes we don't always get to do everything we want to do in your career. Like I said, when I was in consulting, it wasn't always traffic. Sometimes I would do utility design. Sometimes I would do a parking lot design. But I always just looked at it as a new opportunity to learn and to just gain experience. Like I said, I didn't ever think I would be where I'm at today. And so I think these experiences just kind of help round off my tool belt as an engineer. And I really love just being part of stuff like this and having an influence in how things are growing. Okay? Thanks, everyone.
We still have 10 minutes for questions and answers. This is also a webinar, right? So if you want to ask a question, you need to use microphone. Anybody want to ask a question? Maybe while you think about this, I can start a question, Matt. So I know there's a lot of very good ski fields. You're using electric bus, but electric bus battery performance will be poor when the temperature is low. So how did your city address this challenge?
So it's a great question. And, in a handful of years ago, the city said that they wanted to be all electric by 2030. And your point is spot on, that we have a hard time charging, too, in the wintertime because the overhead chargers get covered with snow. So what we're proposing is that we don't go 100% electric, that we still maintain a 20 to 30% diesel fleet. So that way we can still, if we need to bring a truck, we can bring a bus in to charge it, that we can substitute it with a diesel. The technology is just not there yet.
It's catching up.
It's catching up. It's better than it was 5 years ago.
Mm-hmm. Anybody got a question now? All right, so maybe can you pass this to back wheel?
So I was curious, I know you spend a lot of time working with like State Patrol and other agencies like that. Have you found like in all your testing, like sort of how accurate and what the sort of like results are from different like radar systems and methods that those use, and sort of how well like State Patrol and things like that are able to like accurately monitor road speeds?
Yeah. So you're monitoring some different technologies. Like I said, we always used loops for ground truth. Our loops were always 99.9% accurate. Reason for that is because we had to maintain that level of accuracy for reporting to the federal government. That's tied to the state's federal funds. So then when we started looking at different technology like side-fire radar detection, we would use that in comparison with our loops. And I did the same thing with those magnetometers that you saw. Those magnetometers were about 90%. And the way that I tested those is I dropped those right in the center of a loop. And then we would just count, and then we would do a comparison against the loop, and we would do the same thing with the radar. You know, law enforcement radar is different because they're handheld guns, and they bring those in for calibration, right? And so they're trying to maintain those at a 95 to 99% accuracy all the time. When you go to Wavetronics, it's a side-fire radar detector. Those, depending on the situation, they're about 95% accurate. The challenge you have with a radar detector is what they call occlusion. So if you've got a large semi and you've got a small car and they're driving past at the same time, that radar detector may miss that small car because it's blocked by the truck. And there's newer technology that's coming out. I saw some today that was pretty impressive, where it's using video detection, but it's able to create a unique ID on every vehicle, so that when the larger truck passes, it can still capture the ID of that other smaller vehicle. So I think as we move further down the road, I think technology is getting better and better.
Any other questions?
I have a question. Do you think it's possible to redesign American cities to become less car-centric and more designed for just walking or biking or public transportation?
So the answer to your question is yes, we can. But the question is will the public embrace it? I think that's the question, is people like their ability to come and go as they please. And I think that it's either going to have to come to a point to where we prioritize transit, like we're trying to do in Park City, where people on a bus can wave as they go past a car stuck in congestion, to when maybe people will say, you know what, maybe I should park at the park and ride instead of sitting in a car. I think as some cities are getting there based on their congestion issues, I think it will just put pressure to get there.
How did you manage to make all those services free, from like the bus to all of that, and not having to charge the customers? Was it like an allotted amount from your budget or something?
Yeah, so our revenue comes from FTA funds and also from the resorts. We get a lot of sales tax revenue. You know, during COVID, when everything was shut down, Park City wasn't, because Park City was an outdoor recreation place. And so Park City saw some of their highest numbers during COVID because people could play outside. The problem was our buses weren't full because people wouldn't ride the bus. But we were still getting revenue. And so we weren't running as many bus routes during COVID. And so now what happened is we still have kind of a surplus from some of that we are now using to help us with some of these routes. But that's where it comes from. Our bus fleet, 80% of our bus fleet is funded from FTA funds.
Any more questions? All right, so, you know, Matt came just for this lecture from the Park City. Yesterday, the airplane scheduled to arrive at about maybe 7:30, but there was a snow and it delayed his arrival to midnight, right? So
Yep.
getting to hotel at 1 a.m. So clearly, he really summarized very well, you know, the different options in transportation. And Matt goes through, you know, private industry and agency, and from the engineer to leadership role. So you can really learn a lot from him. So I hope you benefited from his lecture. Let's give him a big round of applause.
Thank you.
Thank
Thanks.
you, man.
Yeah, you
So
bet.
I will treat him a good dinner today, just to appreciate my friend.
Hey, thanks.
All right, so the class is over. If you have not turned in your assignment, please do so now. Thank you.